Alright, so we have a question here that reads, a rabbit and a frog are racing. This graph shows the distance traveled by each one since the beginning of the race. If the race lasts half an hour, who will win? So clearly, whoever is traveling the greatest distance at the end of half hour will be the winner. So we'll start with our rabbit, which is the lapin. And I need to determine how quickly he's running, what's his speed, to be able to then figure out how far he'll have gone at the end of that 30 minutes. So we start by seeing that there's no units here. So let's say we're talking about distance of centimeters. We start by seeing that at 3 minutes, he's run 180 centimeters. So I'll start by taking my 180 and I'll divide it by the 3 minutes that he's run. And I get a distance of 60 centimeters per minute. I'll take my next data set, which is 360 divided by the 6 minutes that he's run, and I get, again, 60. If I continue down the table, you can go ahead and do that. You find that our little rabbit is pretty stable in his speed. No matter how long he runs, he's got a speed of 60 centimeters or so per minute, which would be a constant speed. So therefore, I can easily come up with an algebraic expression which tells me then that whatever distance he's going to run is whatever is his speed of 60 times however minutes he's been running. I'm just going to want to quickly do a very quick check. I'm just going to randomly pick one. Let's say this one. I'm going to test it and see if it works in my expression. So let's say I don't know the distance. I want to say that he's been running for 9 minutes. His distance is 540, which is what's up here. So I have a check. I know that this algebraic expression works with this information. So now I go back to my question. My question says he'll have run for half an hour. So let's take my algebraic expression of distance is equal to 60 times the number of minutes. His distance is equal to 60 times half an hour is 30 minutes. And so his distance is equal to 1,800, which is the 6 times 3 is 18, and add in your 2 zeros. So that's the distance after half an hour for my rabbit. Let's go over for the frog now. His data set seems a little bit more interesting because it seems like we're dealing with smaller numbers. So you might initially want to just say as a guess, oh, you know, the rabbit is going to win, but you definitely want to have the mathematical support for that. So let's start. We'll do the same thing we did, which is take our distance and divide it by our minutes. And we get 6 for the first one. Then we get 12 for our next set. The third one is 162, run in 9 minutes, and that gives us 18. 288, run over 12 minutes, gives us 24. 450, run over 15 minutes, gives us 30. So clearly, while we had a constant here with the rabbit, now we have a variable speed with the frog. So I'm going to need to come up with an algebraic expression that not only covers the distance run after half an hour, but actually is going to include a variable in my speed, whereas here I had my constant of 60. So I need to look and see if I can find any relationship that can help me find that variable. So when I take a look at the speed and the minutes, so I'm just going to focus on speeds and minutes, I hope you can see that there seems to be a relationship between the speed and my minutes. The speed is exactly double the number of minutes he's run. So I could actually say that speed is 2 times the minutes. Okay? And his distance, we're going to use almost the exact same formula we had here, except instead of having a constant, we're going to use the speed. So we're going to say that our distance is equal to our speed, which is 2m, multiplied by our minutes run. Before I go ahead and solve thinking I have the right answer, I want to do the same thing I did here with the rabbit, which is I just want to check and see if my expression will follow through with the information given to me. So I'm just going to do a quick check. Again, I'm going to pick randomly. I'm going to pick this number 9, and I'm going to say that, let's pretend I don't know the distance. I'm going to say that he's run 2 times 9 times 9. So 2 times 9 is 18 times 9. Distance is 162. That checks out with my data set. So now that I know that I have the right expression, I can go ahead and solve for how long or how far he'll have run over his 30 minutes. So again, using that same expression, 2m times m. This time, I'm not plugging in something I know. I'm plugging in the question, which says half an hour. Half an hour is 30 minutes. So 2 times 30 times 30. Don't make the mistake of using a squared here. This is not, they're not squared here. Okay? Then I'm going to go ahead and multiply that for a set and get 60 times 30. And what do you know? The frog has also run 1,800 centimeters. So in fact, there is a tie with no winner. And I like to always write a sentence at the end of a word problem. So there is no winner. They will tie the race. And there is our solution to our problem.